We had talked about this function, y equals x squared plus 2x minus 1, had that parabola going on. And we wanted to look at just the slopes of some of the tangent lines and even how they compare to the derivative function. So before, there was another video at x equals 3 and the slope and the tangent line there. So we graphed that one before. We had to zoom way out. It was this very steep line passing through 314 there. We can also see as we zoom in, the vertex there is at -1. So there would be that horizontal tangent line. We also plugged in, I was just plugging in a couple random numbers, -7, and that's going to be way, way up off the screen. I don't know if I really want to chat about this too much, but we can imagine the tangent line way up there, very steep. I'd like to also graph the derivative function itself. So we found the derivative function to be 2x plus 2. And let's just compare the original function, the green one, with the derivative function in blue. So we can see, hey, down there at the vertex where the tangent line would be 0, we see the graph of the derivative is 0 because the graph describes the slopes of the tangent lines. Also to the left, all of those are the negative tangent lines with negative slopes, and to the left of -1, we have negative values. Now they're getting more positive, so they're very negative up here, but as they approach that vertex, they're leveling off. They're getting less and less negative as they approach, and then at 0 right there, then the tangent lines begin to go slightly positive, and then more and more positive, and after that point we have slightly positive, and then more and more positive on the way up. Okay, we're looking at, in part B, it was y equals the cube root. I'm not exactly sure how to put cube root into Desmos. I'm sure it's possible. I'm just going to put y equals x to the 1/3. Oh, excuse me, it's not the cube root. My bad, it's the square root. We did talk about cube root later. I'll bring that back up. We talked about the square root of x cubed. Okay, and we found the derivative function to be, I'm going to go with the simplified version. It's just a little bit quicker to type in right there. And that's kind of interesting relationship between the original function and the derivative. And you can tell, yep, they certainly have the same domain, which is kind of cool. You can tell here slopes of tangent lines right there at the very bottom. If you were to think of the origin, the tangent line there is horizontal, and so the derivative function begins at 0, and then the slopes of the tangent lines get more and more positive, and here these get more and more positive, but they happen to curve the other direction, which is kind of interesting. And then finally, we were looking at y equals 1 minus x over 1 plus x. And if we zoom out, we see that there's a vertical asymptote there at -1. Our derivative function was y equals -2 over 1 plus x squared, that green right there. And that's kind of interesting comparison. So, yep, it also has a vertical asymptote at -1, which we would expect. But then you kind of notice what's happening. So here in the blue, the original function is decreasing, we say. So it's dropping. So the tangent lines are just barely negative up here. So the green's just barely negative. But then they become more and more and more negative. So that green goes more and more negative as these slopes of these tangent lines go more negative. But then kind of notice what's going on the opposite side. When it comes to the other side of the vertical asymptote, the slopes of the tangent lines are still very, very negative. So it begins, the green starts very, very negative, but then as the blue progresses this direction, the slopes of the tangent lines become less negative and end up almost leveling off completely. Of course, there's a horizontal tangent line there. And so what happens to the green? The y values begin very negative, but then the y values get less negative and they tend towards zero as these slopes here tend towards zero. Okay, I think that is all. Oh, yes. Almost forgot. I mentioned it a moment ago. That example, y equals the cube root of x. So I'm going to just put in x to the 1/3. And the idea was there's a vertical tangent line happening there at the origin, and it's really easy to see when it's very nicely graphed here in Desmos. It is a function. It does pass the vertical line test, but just for an instant, right there at the origin, the tangent line is completely vertical along that y-axis, and so the derivative does not exist there. And as I promised, we're going to find through other means the derivative function for y equals x to the 1/3 in 3.1. So look for that. And if you want to come back into Desmos yourself, I won't do it, but if you want to come back into Desmos yourself, you can kind of play around with that too. Okay, that's all I want to say.